Hello, my name is Thanom. I'm from UNSW. Today I'm going to work through some of the calculus problems from MATH1011 from this chapter on surds, indices and logarithms. So starting with question 5, which asks us to simplify some indices that have some numerical values there. So starting with 5 part D, we're asked to simplify 16 on 81 to the power of minus 5 on 4. So we're not using a calculator here. We've just got to understand what does it mean to power 61 on 81 to the minus 5 on 4. So minus 5 on 4 is really three things. It's a minus 1 times a quarter times a 5. Right? That's useful because I know from my index laws that means this is 16 on 81 to the minus 1 all to the a quarter, all to the 5. Okay, so I can just apply each of these powers one at a time. Now when you power something to the minus 1, what you're doing is you're reciprocating it. So 3 to the minus 1 is 1 over 3. 7 to the minus 1 is 1 over 7. If I have a fraction, 16 on 81 to the minus 1, that's 1 over 16 on 81. That's the same as 81 on 16. You can just flip that upside down. So this is 81 on 16 to the a quarter to the 5. So what does it mean to power a number to the a quarter? Well, that means taking the fourth root. So if we take the fourth root of 81 on 16, that's 3 over 2. Because 3 to the 4 is 81, 2 to the 4 is 16. So now we're left with 3 on 2 to the 5, and that's 3 to the 5 on 2 to the 5, and 3 to the 5 is 243, and 2 to the 5 is 32. So this is 16 on 81 to the power of minus 5 on 4, simplified there. Okay, moving on to part E. We've got several components here. We've got our fractional powers here. When you think to the power of a half, that's the square root. The power of 1/8, that's the 8th root. The 6th root, the square root again. But what's the square root of 12? Well, I'm not sure. You can simplify it. It's 2 root 3. But this is quite tricky, right? So I'm going to approach this a different way. I'm going to write each of these 12, 16, 27, 18 in terms of their prime factorizations, just so I can simplify it a little bit easier. So 12 is 2 squared times 3. 16 is 2 to the 4. 27 is 3 cubed. And 18 is 3 squared times 2, or 2 times 3 squared. Okay. And then 2 squared times 3 to the half, that's the same as 2 squared to the half times 3 to the half. That's a half there, not a 1/3. Times, now 2 to the 4 to the 1/8, that's 2 to the 4 times 1/8. 4/8, that's a half. So when I power and I power again, I multiply those indices there. So that simplifies to 2 to the half. 3 to the 3 to the 1/6, again I can multiply those powers. 3 times a 6th is also a half, so this is 3 to the half, times 2 to the half times 3 squared to the half there. Okay, I'm just writing out every step of working here. Once you get used to it, you can do things like 2 squared to the half in your head. So 2 squared to the half, I multiply those indices and I get 1. So this is really 2 to the 1 times 3 to the half times 2 to the half over 3 to the half times 2 to the half times 3 squared to the half, that's 3 to the power of 1. Okay, so I could simplify 2 to the 1 times 2 to the half to 2 to the 1.5, but I'm not going to do that because I can see there's a 2 to the half on the top and on the bottom. There's a 3 to the half on the top and the bottom. So these factors are the same and they divide to give 1. So my final answer, once I cancel these factors, is just 2 to the 1 on 3 to the 1, or 2/3 there. Okay, so lots of ways to approach the problem, but I just approached it by factorizing each of these numbers and then using my index laws. So I didn't end up having to take square roots or eighth roots or sixth roots at all. I just simplified using the index laws and those numbers. Okay, our final part here, part G, we've got powers that aren't just numerical, they've got n's in them, so unknowns. 3 to the power of n plus 4 minus. Now, this is a bit strange. In the notes, they've used a dot here, which is really multiplication, although they've used a multiplication sign on the bottom. So know that this dot here, 6, it's not 6.3, it's 6 times 3 to the power of n plus 1. Okay, so let's start simplifying this. The first thing I'm going to do is write 6 as 2 times 3. Because there are powers of 3 here, so if I want to simplify, I want to be able to group those powers of 3 together. So here I have 3 to the n plus 4 minus 2. Now this is 3 times 3 to the n plus 1, or 3 to the 1 times 3 to the n plus 1. That's 3 to the n plus 2. This is 3 multiplied by itself n plus 1 times, and then an extra 3 means I've got 3 multiplied by itself n plus 2 times. So all divided by 11 times 3 to the n plus 2. Now, this is a subtraction in here. So you can't, lots of people would be tempted to cancel these 3 to the n plus 2's because they're the same on top and bottom. But you have to take it out as a factor because this is subtraction here. So at the moment, this 3 to the n plus 2 is not a factor. However, I can factorize it out because this is 3 to the n plus 4. There's n plus 4 3's being multiplied. I can take out as a factor n plus 2 of them, and inside I would be left with 2 3's, so 3 squared. So this makes sense. 3 to the n plus 2 times 3 squared is 3 to the n plus 4. You would add those indices. If I've taken out the 3 to the n plus 2, I'm left with a 2 on the top, and on the denominator here I have 11 times 3 to the n plus 2. So now, this is multiplication. 3 to the n plus 2 is a factor on the top and it's a factor on the bottom. So they will cancel out and I will have 3 squared minus 2. So that's 7 over 11 left as my final answer. So this one's slightly trickier. You do need to know how to factorize the 3 to the n plus 2 out at this step. And at the end of the day, it simplifies to a nice numerical answer of 7 on 11.